Hello and welcome back to part 2 of KNN with Python. The data was ready for train task and split. So the splitting part is exactly the same as what we have done for linear regression and logistic regression. So hope you do remember from sklearn dot. As I said, you can either pick cross-validation or model selection. The difference is just one is the sublibrary of the other. In this case, I'm gonna select model selection and gonna import train task and split. Train task and split. Okay. And the same here. If you want to save some typing, you can always shift tab to read the documentation. You find one of the examples here, you copy that, and paste it here. Okay, so I'm gonna do some cleanup. Oh, oops, sorry. So, yeah. So what should be my X, the capitalized X? That is the feature clones. So from the previous part, we know the feature columns after standardization is scaled features, right? You can either use this one or you can just use the data frame. Okay, this is, if you do remember, this is the n-dimensional array, and this is our data frame, right? After we convert the array type to the data frame type, you can pick one of them. It doesn't matter which one you use. So, but for this one, I'm gonna use scaled features to replace x here. And how about y? What is y? We know that we're gonna predict target class, right? So y will be the target class, right? And the test size of the 30% goes to testing data at random state. Pick the number 101. If you want to get the answer exactly as mine, you can do 101 as well. Okay, so far we have done the splitting part. Remember that we are trying to come up with a model, right, to predict whether someone will target class or not. We'll start with k equals to 1. From sklearn dot neighbors import k neighbors. So for this one, because that's for classification, right? So I'm gonna just select k neighbors classifier, okay? And then I will build up an instance object. It's called KNN, and I'm gonna call this method again, right? It's exactly the same step as what we have done before. Okay, if we read the documentation for k-neighbors classifier, you'll see it will take some arguments here. So n neighbors weight equals to uniform algorithm. So in this case, the only thing I'm caring about is n underscore neighbors equals to blah blah blah. But as I said, I'm gonna try with. So that basically means how many neighbors do you want to define, right? We'll start with k equals to 1. Okay, so k underscore neighbors equals to 1 for now. Okay, and then I'm gonna fit this model to my training set. So KNN dot what method? Fit, right? So x train, y train, fit that in, okay? And then what should I do? The prediction, okay? So predictions equal to KNN dot predict. What should I pass into the parenthesis? The testing data, right? Okay. So far what we have done is we deal with the model thing. Okay. Now I'm gonna try to do the predictions and evaluations. Okay. So it's mainly for evaluation. So from sklearn dot. Okay, so what library is that? Matrix. Okay, import. So for this one, I will import both classification report and also the confusion matrix. Okay, and I want to print confusion matrix in pass y test and my predictions to the parenthesis. Okay, and then print have the classification report left, y test pred. Okay, looks like the result is pretty good here. Okay, but that'll be fine because we're gonna try picking different k values later on. Okay. So so for this one, we are gonna try with the elbow method to pick the best k value. Because you might say k equals to 1, or k equals to 2, these numbers are too small. It might generate some bias, right? So the good thing, like if you want to pick the good k value, is always to try with the elbow method. I'm gonna talk about this in part 3.